So, friends, today's topic is uh, terminology, different terminology used in Six Sigma and design of experiments. And this is more true for DOE, design of experiments. And though this many people have heard this terminology, but many people confuse here. And I am going to simplify this thing so that uh, it will be easy for you to follow the rest of the uh, so, topics of design of experiments. Actually, design of experiments, the way it is a little difficult subject, and I am trying to make it simpler, and that is why I am reading books, I am going through videos, I am trying to put it. In fact, the whole day I was reading this uh, design of experiments from a book called Montgomery, and also I have made some videos earlier which I was going through it, and I also uh, listened some NPTEL videos. So now, what are the main or important terminologies of this DOE? Actually, this terminology are only five. For example, they are number one is randomization, second is replication, third is repetitions, four is blocking, and fifth is factors, and sixth is levels. On the whole thing, these DOE experiments are conducted. And explaining this topic will take a long time, so I am going to split into two lectures. And this today we will talk of only three, that is uh, randomization, replication, and repetition. DOE's principle, DOE uh, itself is based on the randomization. Why randomization? Because in the plant or in the process, every measurements will not be exactly like the previous one. Every material will be not the same as the previous one. Every people or operator may not be same. So they are different. These are called uncontrollable factors, or these are the factors, they are hard to change factors. And for to take care of this randomization is required. This is extraneous factor, external to your controls. Whereas uh, the controllable variables are the process parameters which you can control, like temperature, time, etc. Now, uh, let's say I have a chemical reactions process where the timing of reaction is 80 to 90 minutes range, and the temperature of reaction is from 170 to 190 range. Now, what I will do, I can set 80 minutes and 170 degree, 80 minutes and 190 degree, 90 minutes and 170 degree, 90 minutes and 190 degree. But I cannot do the experiment in this same order which I told. It has to be in a random order. Why? Because the processes has to be randomized, because it will take care of the change of raw materials or change of the any other parameters which you are not knowing about it. So you have to do in a random order, and normally this randomization is done by the computer when if you are using a software, it will provide the randomization automatically. Now, if you are doing yourself, then you can let's say make a lottery, take number, keep the reading 1, 2, 3, 4, put it there, and take a lottery, and you can do it. Now, let's say uh, this randomization will reduce the biases for any particular thing, like any raw material or any person, like that. It will make it independent of these biases. Now let's say I will further add to it about what is replication is. In the replication and randomization are interconnected. Now let's say replication I want to do many in each setting. I want to do, let's say, four experiments in the same setting. I want to do 4 times. Now, at that particular setting, I can do 4 times, but that will be of no use. So, what I am doing, suppose there are 4 settings, and each setting I want to do 4 times, so totally there are 16 times. So, the 16 times has to be done in a random order, so that this both the randomization will take place and replication will take place. Replication will make the experiment more precise. The variations will, when you use replication, will go down, and the formula is the standard deviation of variation with replication will be square root of sigma, the original the standard deviation, divided by n, where n is the number of replications. So suppose the earlier whatever the standard deviation was there, now if I put n is equal to 4, so if you take the square root of 2, n, it becomes 2, and so the random the standard deviation will become sigma by 2. That means it will become half, so it will become more precise. And now so replication is important. Without replication you cannot achieve it, but of course at some places you cannot have replications, so it is okay. But the places where you have, you at least you have to take replication n equal to 2, and some places you can take n equal to 3 or 4, because it will make it will facilitate for randomization as well as repetition. Now the randomization plus replications. Now third is repetitions. In the particular setting, if you are doing 3 times or 4 times, just to average out the readings, that is called repetitions. So repetitions and replications are not same. In a particular time, if you are doing it, all these 4 or 3 experiment has to be done in the same setting, same time. That is called repetition. So we talked of randomization, we talked of replication, we talked of repetition, and these things are very important. Many people do only in one reading, no replication, no randomization, so that will give all erroneous result. And for the sake of that, if DOE that I am doing this experiment, that is not going to help you. So thank you friends, this is for today, and from maybe the next lecture will be to explain this balance 3 topics. Thank you very much, and have a great day ahead.